Your 4.1 to 4.3 Algebra mid-chapter practice quiz. This should have said practice. We're doing, let's see, about 5 questions, mainly on nonlinear and linear functions, but let's look at also situations. So you're going to need to know what are the variables in this particular graph in this situation. It's dealing with French toast in a serving dish at a breakfast buffet over time, as time goes on. So you're at a buffet at a restaurant, and what exactly is this graph showing as far as the number of slices of French toast happens over a period of time? So first of all, what are the variables? So you should have noticed that the variables are what are on the x and y axis. So the variables are the number of slices of French toast, number of slices of French toast, and time. Time is the x-axis. So time is my independent variable. So time is down here. Okay, and then describe how the variables are related at various points of the graph. So I'm actually not going to write all of this out. I hope you did, because you need to understand this, but I'm going to instead talk you through it. So it looks like the buffet started with several pieces of French toast. 0 would be down here. So they start with several slices of French toast. Then as time goes on, it stays the same, and then all of a sudden it drops down to less than half. So that is a bigger drop than half of the original amount. We don't know what the original amount is, but it drops down. So several people eat French toast. Then time goes on and it stays the same, and then maybe a little bit more is eaten. Then time goes on and it stays the same, and then a little bit more is eaten. There's still some, so there's still maybe, I would say, just one or a few pieces of French toast over a period of time. And then they must have ended up making more, because then at a certain amount of time, a lot of slices of French toast are added. And then once again, time goes by, a little bit is taken, time goes by, a little bit more is taken, and then time goes by with this same constant steady amount. So I'm not going to write all that. I hope you did something similar to what I just talked through, but that would explain how the variables are related as time goes on. Okay, number 2 says sketch a graph at the height of each object over time. So, and then it says label each section. We'll talk about that. Here's the situation. An elevator fills with people on the ground floor. So I am going to sketch a graph. Most get off at this point, blah, 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 all the way back to okay, without any stops. So time is going to be across the bottom. This is the elevator over a period of time. And here are all of the floors. So this is, the height, right? It wants to know, sketch a graph of height over time. So height over time. So we're talking about the height of where the elevator is at over time. Since it gives us specific floor numbers, I'm going to go ahead and number these floors. I think the highest it goes up to is 10th, the 10th floor. So I'm going to put like 10 way up here, 5, 0, 1, 2, 3, 4, 6, 7, 8, 9. Okay. So, and then over time, we don't really know the time, but we're just going to sketch it. It's a sketch. It's a rough sketch, kind of like this French toast problem. So label each section. An elevator fills with people on the ground floor. So they're at the ground floor. Most get off at the 7th. So over time, this elevator is going to go up pretty sharply to the 7th floor. So as time goes on, it's going to stop at the 7th floor. Most get off at the 7th floor. So we're going to give them a little time, because that's most of the people. I don't know how many people were in there, but we're going to give it a long period of time where the elevator is not moving, because most of these people are getting off. Then the remainder get off at the 9th floor. Okay, so we're going to go up a little bit more shallow of a section, because it won't take as long to get to the 9th floor. The remainder get off there. So there's I would say a little bit of time that needs to stop. Maybe not as much as the first pause, because that was most of the people. However, in this section, the remaining The remainder get off. Then it says, then 2 people get on at the 10th floor. So we need to go up again to the 10th floor, let a couple of people get on. So we're going to pause there. And then they get lowered all the way back down to the ground floor without any stops. So this one can be a little bit sharper. It can be a little bit faster declining because there's no stops in between there. All right, so this would be my graph over time of height of the elevator over a period of time. The part that says label each section, that basically is just that right here we know that it is increasing, height is increasing. Here, when it paused, it stayed constant. It stays constant. Oops, stays. Here it increased again. Here it stayed constant again. Here it increased again. Here it stayed constant again. And then here it declined pretty quickly. You can just put declined or decreased. Increased, decreased, probably should have been decreased. That's okay. But that is how to label each section. Okay, for the last part, it says, I'm so sorry that it's saying to identify all of these things because using words, using an equation, and using a graph is something that I didn't give you a lot of space for. So I will do my graph over here, and I'll just do the best I can do. On your actual quiz, this will be here for you, so you won't have to freehand it. So let's graph it. Cans of soda, wait, I didn't read it. For each table, identify the independent and dependent variables. So to identify the independent, that will always be your input or your x's. So I'm going to put an I here. And then dependent would be the soda in ounces. So that is always my y-axis. This is my x. This is my y. My x is my input value. My y is my output value. Independent and dependent variables. Okay, so the number of cans of soda will be my x-axis, so that's 0. 1, 2, 3, 4 is how big it goes on the x-axis. 12 all the way up to 48 is what I need on my y-axis. So I'll just count by 12s. 12, 24, 36, 48. All right, at 1 can of soda, there's 12 ounces. 2 cans is 24, 3 cans is 36, 4 cans is 48. So you can see this is very linear. It's increasing by 12 each time. So when I say, what is it in words? My words would be each can of soda has 12 ounces. So every new can of soda will have 12 more ounces. Okay, then it says to write it in an equation. How do you get from 1 to 12, 2 to 24, 3 to 36, 4 to 48? You're just multiplying by 12 each time. So your equation would be to get your y, which is your output, you take your x, which is your input, and multiply by 12. So your equation is y equals 12x. And I already did a graph over here. Okay, let's try the next one. Dog biscuits left. So I'll just make a quick graph off to the side. This is my independent variable. This is my dependent variable. These are my x's. These are my y's, my input, my output. So for the x-axis, I probably should have labeled these. Cans, ounces. So down here is going to be tricks. And up here is going to be biscuits. Number of biscuits. Okay, the amount of tricks goes from 1 to 4. So 1, 2, 3, 4. I like to always include a 0 on there. Number of biscuits goes from 20 down to 11. So the highest it goes is 20. Halfway would be 10. There's 5. There's 15. That's fine. Again, this won't be here for you to sketch. There'll be something better. So 1 trick, 20 biscuits. 1 trick, 20 biscuits. 2 tricks, 17 biscuits. Ooh, this can be hard to fit on there, but that's okay. We'll just try. 3 tricks, 14 My numbers might not exactly match up. That's okay. 4 tricks is 11. So you can actually see it is linear. If you're not sure, go ahead and check. This is subtracting 3, this is subtracting 3, this is subtracting 3, this is increasing 1, increasing 1, increasing 1. So again, this is constant because it's doing the same thing each time. In words, I would describe this by saying each trick, after each trick, let's describe it in words by saying after each trick, I have 3 fewer treats left, or something like that. Okay, and then the last thing is an equation. If you watched my video on 4.3, you saw my quick little way to come up with an equation if you're not sure. So my quick reminder is whatever it's changing by over here is what's multiplied by your x. So this is -3 since it's subtracting 3. So -3x. But then that's not all. It'd be plus or minus something, because 1 times -3 is not 20. 2 times -3 is not 17. So you're not done. You have this part from our constant, but then you need to add or subtract something after it too. So here's what I told you guys in the previous video. I said if you know what 0 is, this is the number you start at. And so we could actually work backwards. We could go 4, 3, 2, 1, 0. What would be over here? 11, 14, 17, 20. What would the number above it be? If we're working backwards, that would be 3 more. So it would be 23. And if that's a positive 23, then we could do plus 23. If it was a negative 23, it'd be minus 23. But I always want you guys to double check this. This might not be the equation. Let's make sure. What is -3 times 1? It's -3. If I add 23, does that make it 20? Yes, it does. Let's check with 2. 2 times -3 is -6. -6 plus 23 is 17. So that does work. 3 times -3 is -9. -9 plus 23 is 14. So this does work. 4 times -3 is -12, plus 23 is 11. So this is my equation. It was a little hard. I think you will not find as hard of questions like that on your test yet. Later in algebra, absolutely. But for our purposes for this week, I think you'll be okay on this type of problem. It'll be more like this. It'll be more like something proportional. Okay. These last ones are going to go super fast. Linear or nonlinear? Remember, linear means there's a pattern that's constant. This looks like it's adding 2 each time. This looks like it's adding 1, 1, 1. So yes, this is linear. Cool. Let's check the second one. This is adding 0, adding 0, adding 0, adding 2, adding 2, adding 2. They're doing the same thing. They're doing the same thing. This one is also linear. All right. This one is subtracting 1. Subtracting 1. Ooh, that added like 11 or something, right? That might not be right. Something. This added 1, added 1, added 1. I mean, honestly, we could have stopped down here and we could have gone, okay, wait a minute, that's not going to work. So when I graph this, it's most definitely going to be non-linear. All right, let's try the last 4. They're the easiest ones on the paper. You're just looking for a straight line or a curved line. Curved lines are non-linear. Straight lines are linear. And now I'm getting lazy and just marking it with L or NL. So curved lines, non-linear. Straight lines, even if there's not a line drawn through it, if you can just see the pattern is constant, it is linear.